Okay, one last day of dividing. Doing the factor theorem. The basic idea here is that if you can divide your polynomial by something and it works out perfectly, then it's a factor. And if that's the case, if you're left with something in a quadratic form, you can then factor that to get all the remaining roots or solutions, zeros, whatever you want to call them. So let's see what we're doing here. So we've got our problem here, x to the third minus 7x squared plus 7x plus 15. So I'm going to set up my synthetic division here. Since I'm divided by x minus 5, I'm going to put positive 5 on the outside. And then I go through the same steps we've been doing. So I'm going to bring down my 1. 5 times 1 is 5. Negative 7 plus 5 is negative 2. 5 times negative 2 is negative 10. 7 plus negative 10 is negative 3. 5 times negative 3 is negative 15. And that would give me 0. So there's no remainder, which means x minus 5 is a factor. So I'm going to rewrite this. So I have x squared minus 2x minus 3. And now all I want to do is I want to find the remaining factors of this. And so we could think back to when we first did quadratics. What can I multiply that'll give me negative 3 and add up to give me negative 2? And hopefully you remember factoring enough to know that that is x minus 3 times x plus 1. Right? Since our number at the end is negative, we know we need opposite signs. Since our number in the middle is negative, we know that the negative number has to be the bigger of the two values. And that gives us negative 3, positive 1. And then we bring back our original factor, so x minus 5. So then this becomes our answer, and that's equivalent to our original statement. So we can rewrite x to the third minus 7x squared plus 7x plus 15 as just x minus 3, x plus 1 times x minus 5. Okay, and then that becomes your solutions as well. The three solutions to this equation would be at positive 3, negative 1, and positive 5. In case you wanted to graph it and you didn't have a graphing calculator handy. Let's try one more just for practice. So again, we start with the synthetic division. So I'm going to write all my coefficients. So I have 1, negative 10, negative 8, and then x plus 2. So I'm going to put the opposite, so minus 2 on the outside. We go through, bring down the 1. Negative 2 times 1 is negative 2. Negative 1 minus 2 more is negative 3. Negative 2 times negative 3 is negative 6. Wait a minute. Positive 6, sorry. Negative 10 plus 6 is negative 4. Negative 2 times negative 4 is positive 8. And again, that's what we're looking for. Since the whole idea is factor theorem, if you get a remainder, then the math has gone wrong. Okay? If this was mixed practice, sometimes you'd get a remainder. But since this whole paper says the factor theorem, that means x plus 2 really needs to be a factor. Otherwise, we can't do anything else. So that's going to leave us with x squared minus 3x minus 4, which is pretty similar to our last example, but that's okay. So what can I multiply that gives me negative 4 and adds up to negative 3? Well, the only factors of 4 are 2 and 2, and 4 and 1, and negative 4 plus 1 gives me negative 3. And then don't forget what we divided by. Since it divided evenly, that needs to be a factor. And then that is our whole solution. Okay? So just 2 steps on every problem. Do your synthetic division to get a quadratic equation, and then factor that quadratic equation like you know how to do, and then you will get a 100. So good luck. Have fun. Let me know if you have any questions.